Hello everyone, I'm Chaminda and today we are going to learn about forces in trusses. In this video, I'm going to give you an introduction about trusses. Okay, first we will see what is meant by a truss. A truss is a form of structure composed of slender members joined at their ends to form a rigid structure. It provides both economical and practical solutions to some of the important civil engineering problems. Trusses are commonly used to construct roof structures and bridges. Wooden struts or steel bars are commonly used as members of trusses. Now, when we look at this picture, roof and bridge in the left hand side is built by using several number of roof trusses and bridge trusses. From that, we are going to define plain trusses and space trusses. Now, when the members of the truss lie in a single plane, and that truss is called a plain truss. You can see roof truss and bridge truss in this picture are plain trusses. So space trusses are simply 3D trusses made by joining several number of 2D plain trusses. So in this course, we will only be dealing with 2D plain trusses. Now when we consider about the connection of a truss member, it is connected with pin connections where no moments can transfer from one member to the other. Therefore, the truss members are only subjected either to direct tension or compression, and it is transmitted from one member to another at the joint. Also, we should note that all the loading are applied only on the joint and not on the member. There are different types of trusses used in the industry. For an example, depending on the factors such as span and slope, you can see different truss types in the figure used in roof construction. Similarly, these are some typical types of bridge trusses used in the industry. Right. Here, we are going to learn about statical determinacy of trusses. By referring to your previous lectures, you know what is meant by statical determinacy. Here you are going to check whether the truss is stable or unstable or stable, but you can't calculate the forces using the statical equilibrium equations under this topic. Let's say if the total number of joints in a truss is J, then there are two J equilibrium equations since every joint of a truss in equilibrium is itself in equilibrium. So that calculates the number of equations as 2J. And we should know the number of unknown forces. Now those are reaction forces plus member forces. That is M plus R. Now if the truss is statically determinate, then number of equations should be equal to number of unknowns. So we can conclude that M plus R equals 2J, then that truss is in statical determinate and stable state. Therefore, if the M plus R is less than 2J, then the truss is unstable. Also, if the M plus R is greater than 2J, the truss is stable but statically indeterminate, which is it is stable, but we can't calculate the member forces or reaction forces using the statical equilibrium equations. We'll do some examples and get this idea clear. Example 1, you can see a truss with 4 members connected with 4 joints, and in the left hand side it's a pin support and the right hand side it's a roller support. Now you know that for a pin support there are 2 reactions, and for a roller support 1 reaction. So as there are 4 joints, J equals 4, and also 4 members, M equals 4, and 3 reaction forces, R equals 3. And there you can calculate M plus R, that is 7, and 2J, that is 4 into 2, that's 8, which means M plus R is less than 2J. So you can say this is a unstable structure. Even by looking at this truss, you can see it's a unstable structure. Example number 2, as in this example number 1, I have included another member, a diagonal member to the structure that we have discussed in the example number 1. Now how many members in this structure? That is 5. So M equals 5. Still the joints are 4, and obviously you have 3 reactions, 3 reaction forces. So now M plus R is 8, where 2 times J is 8, which means M plus R equals to 2J. So we can say that this structure is statically determinate and stable internally and externally. Let's look at this third example. I have included another member to the example number 2 structure. Now altogether we have 6 members now. So the joints are 4, reaction forces are 3, only difference is we have 6 members in this structure. So M plus R is now 9, 2 times J is 8, which means M plus R is greater than 2J. So what we can conclude from this equation is this is a statically indeterminate structure but stable. Now another thing I have to point out here, we have marked the 2 diagonal members crossing the point as no joint. So no joint member is a member which cross over each other without interconnection. Now with that introduction, let's learn how to analyze a truss. It is very important to analyze the trusses and find the forces of truss members to design trusses. There are 2 common methods used to analyze trusses. The one is method of joints and the other one is method of sections. In my next video, I'll explain you how to analyze a truss using these 2 methods. Thank you.